which is definitely less algebraic. The back part of the course is the probability statistics part of the course. It's the part that I'm most excited about in 105. I like the modeling. I do. I like the modeling. I like the pattern finding. I love the fact that you guys can calculate an instantaneous rate of change. I do like that. You can figure out how fast something is going based on data. That's cool. I like the exponential regressions. I like being able to understand how things change exponentially. I was just reading last night, there's an article in The Source about Ben's new housing bubble. The new housing frenzy that's going on right now with houses flying, being on the market 2 and 3 days. Was that it? No, what was that? That's okay. We should be critical.
I think it's a facade, it's not real.
We should be critical, not necessarily negative. We should be skeptical. Skeptical is like nice negativity. So we should question data. I didn't see one data point in the article except for a couple percentages thrown out without context. I'm with you though. We should be skeptical. Absolutely skeptical. Scott, go ahead.
Well, I was just saying there was like a couple years ago that the real estate agents were actually increasing like potential sales as sales to increase the numbers. So basically what it's saying is you better get on this house because whatever, and they're trying to artificially buffer the cost.
I didn't know that.
Yeah, and if you actually look at potential sales that they run versus actual sales, it's actually quite a bit less.
Quite a bit different, yeah. That doesn't surprise me.
Yeah, so.
That doesn't surprise me. It's about 3 or 4 years ago, we talk about measures of center. I hope to have enough time in this class to talk to one of the last things we'll do is talk about measures of center. Averages, medians, modes, those kinds of things. You probably heard of some of them before. And everybody learns how to do an average, like in grade school. We all learned that at a very young age. But then when I ask students when you should and shouldn't use averages, it's a totally different question. And one of the places you should not, in general, use an average is in real estate. When you're talking about the average home price, it's generally a pretty bad idea. You want to use what's called the median home price. And if you've taken statistics before, you understand why. An average can be greatly influenced by what's called an outlier. Give you an example. Indiana State University, back in the 70s, put a recruiting pamphlet out for their business program. And the recruiting pamphlet said, on average, the holder of a bachelor's degree in business from Indiana State University, on average, makes $10,000 more in their starting year than the graduate of any other school with the same degree. Now this is in 1970. Now $10,000 is a lot of money regardless, but imagine it in $1970. And it was true. It was extraordinarily true. So if the curriculum were so similar, what made Indiana State University's average starting salary so much greater than all these other schools? Kelly, what do you think?
Because one person that got hired out of that school made $200,000 a year, whereas everybody else only made 60 or 80.
It's 100% correct. It was even more than 200,000 because one of the people that graduated from Indiana State University in the 70s went on to play basketball for the Boston Celtics. Larry Bird.
Oh, gee.
And they went ahead and put his salary in there.
Wow.
So, were they lying?
No.
Were they lying when they said no? Were they being a little misleading?
Yeah.
Perhaps, yes. That's article, right? I think I'm skeptical. Maybe even negative, but skeptical. They should have used the median salary, which wouldn't have counted the size of Larry Bird's salary, just the fact that it was the greatest. But you can hit the nail on the head, Kelly. The problem with averages, and this happens with house prices. When a big house goes into a neighborhood, it drives all the apparent average prices of the houses up because the average moves toward that large house. Conversely, if you put a smaller, this is going in my neighborhood right now, people are getting pissed off because somebody's building a 1,500 square foot house in their neighborhood. Oh, we're going to drive house values down. It's like, no, I think the Bend housing market did a pretty good job of that already. I think it's awesome somebody's building a 1,500 square foot house versus a 2,500 square foot house. Oh, but the housing values, I'm like, please stop. But the point is that yes, on average, our house prices are going to go down if that house costs less, because the average chases those things called outliers. So that's kind of the flavor of the rest of the course, if that makes sense. That kind of idea. So I was trying to think of a neat way to kind of motivate this part. Anybody, speaking of the 70s, anybody remember the show Let's Make a Deal? You're all too young for this, that's okay. Couple of you do. Well, the show still goes on, right? With is Wayne Brady, is he hosting it now, or Drew Carey?
Yeah, Wayne Brady.
Okay, well I'll talk about the original, hosted by a good-looking gentleman, Monty Hall. The basic idea was simply you dressed up like a moron, and there were 3 doors. Now I'm going to strip this down because Monty was a savvy businessman. This show was riotously popular. The basic idea was there were 3 doors, and there's behind one of the 3 doors was something that you wanted. It was usually like a car or like a living room set, or something very, very nice. Now, often there was like a smaller good prize behind another door, and then the other door had like something you didn't want, like an animal, a goat, right? A goat or something like that. Exactly. Very nice, Cheryl. Exactly. Let's strip it down and make it even easier. One of the doors has something you want behind it. The other two have nothing behind it. Because that's at heart, that's kind of the way the game was played. And here's what happened. He then said, okay, you, Mr. or Miss Dice there, you pick a door. And Mr. or Miss Dice picked a door. And then Monty said, okay, you pick, Mr. Dice picked door number 2. Door number 2. So door number 2 is now marked. And then Monty opens one of the other doors, say door number 3. And there's nothing, there's the goat. The goat's behind that one. And then they say, okay, Mr. Die, you took door number 2. You picked door number 2. Door number 3 has nothing behind it. What do you say? Do you want to stick with your door number 2, or do you want to switch to door number 1?
And I'll give you $100.
Right.
And often, this pocket of his up here had lots of money in it, yes, and he would produce dollars to try to buy your door, you know. So the question then remains, taking the money away from it, which was definitely a cool part of the whole, should you switch? Should you keep your door, or does it not matter? Now this is a very famous mathematical puzzle. If you know the solution, don't give it right now. It's called the Monty Hall problem. Well, I shouldn't say it's very famous, it's sort of famous. If you followed things like Marilyn Vos Savant and Parade magazine, you may have heard the solution to this. So if you know the solution to this, there is definitely a solution as to what you should do. But if you've never seen the solution before, what does your gut say right now?
Stay.
Your gut says stay.
Yeah.
Why?
I don't know.
You don't know, but the gut says that.
Yeah.
Don't question my gut rule. Gut says stay. Trust your first choice. I got no problem with that. Echo?
It's still a third chance.
It's still the same chance?
Yeah.
So it doesn't matter what you do?
Yeah.
Okay, so that would go with stay or switch, I guess, wouldn't it be? So we have a vote for stay. We've got a vote for it doesn't matter. Go ahead.
Is stay, just because changing anything is just a risk.
Okay, so the risk of changing, Kate, outweighs the safety, if you will, of staying. It'd be great if we could measure that somehow. But I like that statement. That the idea there's a risk allotted to that. We're going to study more of that in this class towards the end. Good. Ben, what do you got?
Well, I know that in the film 21.
Good. You see this puzzle.
they
Hold
give-
that thought. Hold that
they
thought.
give the answer.
If you
I won't-
see-
I won't give it.
Good. Yeah, if you've seen the movie 21 with Kevin Spacey, which is a pretty decent version of a really, really good book. If you've seen 21, the movie 21, you guys know the answer to this puzzle then. I forgot he did that in that movie. There's a great, that movie came from a book called Bringing Down the House. A couple of you got a chance to read that. Penelope, you've read it, yeah. It's a fantastic book. The movie did a pretty good job with it, but the book is, I think, way better. Nobody got beat up in reality. Nobody laid a hand on anybody in reality because they can't do that. They can't do that. You can't beat somebody up because they counted cards. It's not illegal. They just don't want you to do it. But anyway, the book is fantastic, and I think it does a slightly better job of understanding what mathematics went on with those kids was it MIT? It was MIT, right? Yeah. Wonderful. Very simple mathematics, and actually based on what we're talking about right here. So, I figured rather than have you guys try to struggle through what is actually going on with this, I figured we'll just play the game. I built a set of doors.
Oh, good.
I've got some lollipops.
Is your wife pissed your cabinet's messing right now?
What's the matter?
Is your wife pissed you took off the cabinet?
I got these from what's that place down on 8th? Packet. I got them from Packet.
Nice.
Yeah. I ripped the doors off. We built Max a set of shelves from an old series of kitchen doors, and I kept the doors. I'm like, oh, that's a great little Monty Hall simulator. Of course, I could have made it out of car, but the thing weighs like 80 pounds. I was walking back over here. I'm like, I gotta carry this back plus this freaking stand. This campus keeps you in shape. I'm not gonna lie to you. All right, so let's do this. Let's do this. Swing her over here. Okay, so what I'm gonna do is I'm gonna use my TI to tell me a random door to put a lollipop behind. You guys don't need to use yours right now. We'll have you use yours in a little bit. But what I'm going to do is I'm going to generate a random, let me show you what I'm doing here. Let me show you what I'm doing. Power on. Turn this over here. Okay, so this should work, I think. Yeah. I'm going to start using this instead of the over. I think this will work better. Because you can actually see what buttons I'm pushing too if I'm moving stuff around. So anyway. So in your math menu, this is what I'm going to be using up here. If you go over to the menu called PRB, which is probability, you have this command down here called randint. And randint allows you to generate random numbers between two numbers. So if I go randint 1 to 3 and just press enter, it'll generate random values between 1 and 3. Every time I push it. Okay? Yeah. What's up, Tim?
That's what we were playing with for the quiz, right?
You will be, yeah. This is what you'll, if you've tried the quiz that I originally do today, you actually have to use this command.
Yeah.
If you didn't, you'll see it on Thursday if you try to do the quiz. So basically the idea is it's going to generate numbers, but I'm not going to let you see that, obviously, because I'm going to hide it back here and put the lollipop behind one of those doors. And then I'm going to ask you guys to play the game and see if we can simulate. What we're doing here is actually fusing statistics and probability. Statistics and probability. Let me mute this. Put this up right now. So what I'm going to do first, let's see, that's a broken one. That was not broken. All right, and it's going to be a little bit weird because some of you guys are in front of me, so we're going to negate you guys from the play unless you want to move to the back. So this is not the greatest setup for this. Jen, you weren't looking up here. That's perfect. Let me play first. Pick a door, any door. I placed the lollipop behind one of the doors. Your job's pick a door. She's going to go number 2. I'm going to show Jen that door number 1 is empty. So now Jen has a choice. She can stick with door number 2, or she can switch to door number 3. So the question is, what should Jen do? What do you think, Jen? Your call. Keep door 2.
Switches?
We'll say that
You're
again.
gonna throw the pen in if she switches?
Throw the pen in.
Yeah, pen.
This here? Throw the pen at her? Oh, throw it in. Not throw it at her. I'm not going to throw the... No. So what do you say, Jen? Keep, switch. What do you think? Stay? It's actually over here. Behind door number 3. That's okay, because everybody wins in rules class. So, but I do want to keep track of data. That was a stayed and lost. And I'm going to put lost in quotes because nobody actually loses in here. Because this is not how I play the games. We just lose. All right, so let's pick another flavor. We got yellow, which I'm assuming is lemon. 3. Kate, the board is yours.
Door number 1.
Pick door number 1.
Good
Door number
choice,
3
Kate.
is empty. You can keep door number 1, or you can switch to door number 2.
I'm going to stay in door
Whoa.
There it is. And the Aries system of these things, I need to get dum-dums next time, less Aries systems. So that was the state and lost, wasn't it? Okay, good.
Wait.
All right, let's try another one here. Purple. Purple. Tiffany. Pick a door and a door. Door number 3. Here's door number 2, empty. Keep 3, switch to 1. Your call. Stay with 3.
This isn't working.
What's not working?
Our plan is not working.
Cover your eyes! That made it like a third of the way. So we got stayed and lost. So Cheryl has a vote. Cheryl's saying maybe we should change our strategy. Well, let's find out if green makes you green. Huh? Cheryl, go ahead. The board is yours.
Okay, I'm going for door number 2 again.
Door number 2.
And I'm changing it to door number, oh,
Now you're
Well, you can. That's fine. I was going to potentially. Here's a question. Cheryl actually brings up a really good point right now. Before I even opened the door, she had already decided she's going to switch off the door. Does that imply something?
Yes.
What does that imply?
That we're losing.
What does it imply if she chooses what she's going to do before I even open the door? What does that actually imply about my opening the door?
that I didn't win at door number 2.
Well, that you don't even have to.
That we don't even have to know what door I'm going to open. So keep that in the back of your minds. It might not even matter that I'm showing you or not showing you a door. That might be irrelevant. Okay, so you pick door number 2.
Yeah.
Okay, here's door number 3 empty.
Oh.
Keep your 2 or switch to 1.
Yeah? What? Switch to 1.
Switch to 1?
Yeah.
It was actually
Oh,
Here we go!
Oh.
Yeah. So that was a switch and lost. At least I got a different outcome on the board. That's a switch and lost. Okay, this is good. This is good. This is good. Let's keep going. Let's keep going. Let's keep going. Let's try purple again. That's got no stick. Let's try yellow. Sydney, you were looking down. Perfect. Any door, any door.
Door number 3.
Door number 3. Here's door number 2 empty. Stick with 3, switch to 1.
Switch.
Switch to 1. Who's actually over there behind 3?
This isn't working.
This is not, what's not working now? We're trying everything.
The last one wasn't working either.
What's that? What do you think I go?
There's a 2/3 chance that it's not behind the door you choose.
There's a 2/3 chance that it's not behind the door you choose. Do you believe that?
Yes.
Do you believe that?
I totally.
So I'm going to put that over here on the side. Actually, I'll put it right here because the camera's pointing this way. So there's a 2/3 chance that the lollipop isn't behind your door.
But wait, that changes.
It changes.
Open the door.
Okay, so here's a series of claims.
Okay.
Okay, number 1, there's a 2/3 chance lollipop isn't behind your door. I'm going to put a subclaim of 1A on that way. That means there's a 1/3 chance you're right.
Right.
Did everybody buy that?
Yeah.
There's a 1/3 chance that you're right when you picked your door originally. Is that a fair? It's a fair extension to the 2/3 that basically 2/3 chance you're wrong and a 1/3 chance you're right. I think that makes sense.
Yeah.
First of all, let me ask another question too. What does it mean to be 1/3 right? What does that mean?
That I'm arguing
That
with
you're 2/3 wrong. That's a good answer. Good answer. What does that mean? Explain being 1/3 right to me. Actually, you actually can do a pretty good job using the data that's already happened if you paid attention to what happened. If you paid attention. Let's do one more game real quick, before we get back to these questions. Okay, one more game real quick. Back to yellow. Hey, hold that thought, Kate, okay? Hold that thought. Gabe, where's yours?
Let's go 3.
Go 3. Here's 2. You want to stay with your 3 or switch to 1?
Let's stay.
Stay with 3. Now,
This is my mom.
this is perfect. This is mind-boggling. Actually, believe it or not, you have perfectly answered what it means to be 1/3 correct with where the lollipop is, with those 6 data points right there. Look at those 6 data points. No, it doesn't. Watch this. This is beautiful, Amy. Hold that thought. That's going to be claim number 2. Here's the deal. If you stayed and lost, that must imply that the lollipop isn't where you said it was. Right, that has to explain that, doesn't it? Let's put this up here so you can see all these claims and these wonderful results. So if you stayed and lost, that means you picked the door, there was no lollipop behind it, you stuck with that door, and eventually I opened some other door that had it behind it. Does that make sense? So if you switched and lost, that means you had the right door, but then you switched off of the right door to a wrong door. So in these 2, that means the lollipop was behind your door. Now, we did this 6 times so far, right? 6 times so far. 6 times. Of the 6, how many times did you guys pick the correct door off the bat? 2.
Oh, someone got close.
2. 2 out of the 6, you guys guessed the right door in the beginning, which is 1/3, which agrees beautifully with the 1/3 chance that you're right. It's very rare that it happens that quickly, but yeah. So the other 4 of the 6, or 2/3, guessed the wrong door. Now hopefully that makes sense. There are 3 doors up there. There's 1 lollipop behind one of the 3 doors, and you're essentially randomly guessing to decide where it is. So 1 and 3 makes perfect sense, doesn't it? And that's the only number you need to decide what you should do when I give you the choice to switch or not. What do you think, Scotty?
what about like outside factors?
What's the outside factor?
Well, like a good example is when you rotated it, you would look down to make sure it didn't fall. So your eyes would actually look at the one it was behind every time. So like when he grabbed the last one,
That's some psycho stuff right there, man. I have no idea. If I was doing that, that was completely unintentional.
well, it is. It's just human nature. We do things like
I'm
that.
gonna watch that later.
So yeah,
I am so gonna watch that. So now here's, Scotty, more on that. In years past when I've done this, I've been told that I made certain body movements to imply, I swear to God, I'm paying attention to what I'm doing, obviously not to everything I'm doing, to try to make sure I'm not. Like I try to come straight up. You know, I mean, I'm trying to, I want to look at that though. That's curious you say that. I can't measure that factor. And if I could measure that factor, that means that you guys could too, which means you could use it to your advantage. Good for you.
only if you
Go home and watch
What
YouTube.
was that again? Well, maybe not, but this is only 6 data points. I say we play it a few more times, and then I've got a Monte Carlo simulation to actually show the results. So I saw a couple of hands go. Kate, you've been very patient. Go ahead. You were going to say something earlier.
Yeah, I gave you a minute to remember what it was. Oh, yeah. Oh, yeah.
More sugar.
You have the 2/3 chance of getting it right off the bat.
Wrong right off the bat.
Well,
There's only one lollipop up there.
that's what I meant, 2/3 wrong.
Good for you.
1/3 right. But after you open the door to show us that there's not one, then don't you have a 50% chance of getting it right? Or
Which
wrong?
agrees with what Amy said about 3 minutes ago-ish. So this is claim number 2. Once the door is open, and I'm always going to open the door, right? It switches, I shouldn't say that. The probability changes to 50%. I would only agree with that claim if what happened after I opened the first door.
Right.
Say that again, Kurt.
The lollipop wasn't actually behind it.
I would only agree with that if I moved the lollipop after I opened the door. Did I do that?
No.
I didn't do that at all, did I? I see what you're saying, friends. You're saying there are now 2 doors instead of 3. There are now 2 doors instead of 3. And you're saying, well, if there's 2 doors, that means I have a 1 in 2 chance of having the lollipop behind one of them. But that's not true, is it?
No.
That's not true because if you pick the correct door, or if you pick the correct door off the bat, the lollipop is behind that one right there. But what's the chance you actually did that? 1 in 3. You can't ignore that 1 in 3. That 1 in 3 has to play in. By saying it's 1 in 2, you've eradicated the point that that 1 in 3 even existed. But that has to be counted for, doesn't it? The 1 in 2. To counter the 1 in 2 claim, could you guys give me, I'm going to say maybe 10 minutes? We'll come back to that 1 in 2 claim and show you why it's... There are 2 outcomes, but you can't say it's 1 out of 2 because 1 out of 2 assumes that both outcomes occur with the same frequency. And they don't, because you guys just proved that there are 3 outcomes. And the 2 outcomes, you picked the right door or you didn't pick the right door, are not equal frequency. One happens twice as many as the other. The fact that you're wrong, you're twice as likely wrong as you are right. You're twice as likely wrong as you are right. Now, let's do a few more trials. Let's do a few more trials. Let's do a few more of these. Let's get some red ones in here. What do you say I'm doing, Scott? So when I stand up, that's when
No. When you rotate it, you look down out of the corner. You go like do this.
I thought I rotated from up with the pop in.
No, when you
rotate it, you look
Right.
down real subtly. You'll be like, it's right before you
I thought I rotated it before I put the lollipop in, like I just did right now.
No, you
I straightened it.
because you
After you open one door?
Yeah, you
yeah, you rotate it.
to the person,
After I put this in?
yes,
Yeah.
then you
And you
decide
look
who
down
you're
to
gonna.
verify that.
But I just
So-
rotated before I put it in. Maybe I'm thinking about it now.
Don't get self-conscious. Stay down there.
Anywhere.
Kelly, go! Pick a door!
1,
Door number 1. There's 2. Stay with 1. Switch to 3.
1, 2.
Stay with 1, and there it is! There it is! That was just, oh God! Sorry, Penelope. That was stayed and 1. Now, there is another option we haven't seen yet. And this is just a factor of the fact that we've only played 7 trials. It would be, what would the other option be? Yeah, excellent. Stayed and lost. We got all the switch. Oh no, switched and lost. Thank you. Switched and
No,
lost.
switched in one.
Switched and 1. Yeah, what you guys said. Whatever's not left, thank you for realizing what's not left. Good. Let's do a couple more. Let's do a couple more. All right, let's go with, what colors do I have left? I got a dum-dum. This will be less dangerous if I throw it in the air. Freaking self, it's like a ball around the entire game now. Katie! Yeah, look right, Katie. Look right, Katie.
Door number 3.
Door number 3? Here's door number 2. Stay with 3 or switch to 1? Switch to 1? There it is over there.
You did it again. You did look.
I did not! What the hell did I do? I was looking right at Katie!
Sean, when Kelly picked 1,
When Kelly picked 1,
I instantly said pick 1 because your eyes went down to 1.
I need to be. What was that, first of all? I'm sorry. Was that switch and lost?
Yeah.
I need to be more of a robot. I can't do this, I'm Italian. Okay, forget it. Obviously this is rigged. So, and not because I want it to be, but because I'm an idiot. So, what we're going to do instead is I created what's called a Monte Carlo simulation of this game.